Okay. So what we're going to do is we are going to balance first the Okay. You're going to balance C first, you're going to balance H second, and you're going to balance O third. Okay? It spells C-H-O. Cho. That's the order you want to balance your elements in. Now, we're going to try fractions here. And the reason I'm having you try the fractions is because if you learn this method, it is a powerful tool not only for combustion, but also for some other reactions where you can be sitting there pulling your hair out, and if only you could use a fraction, life would be so much easier. On the other hand, there's another method that people like a lot better usually, okay, and I'm also going to teach you that one today, but if you feel your brain is able to do the fractions, I would recommend trying the fractional method and working with it a little bit so you get experience in working with fractions, okay? But if you hate it, just go with the other method. But for now, we're going to use a fractional coefficient on the O2. And by fractional coefficient, I don't just mean any old fractions. We're going to be talking about either 1/2 or 3/2 or 5/2 or 7/2, or what would our next one be? 1/2, 3/2, 5/2, 7/2, 9/2. And next would be 11/2. And we could go up to like whatever, okay? The deal is this: if you have an oxygen molecule, it is made of 2 oxygens. So you can only get an even number of oxygens, right? If you have a whole oxygen molecule. But very often, maybe on one side of the equation, you've got 5 oxygens, and on the other side of the equation, you've got an O2. Wouldn't it be nice to be able to get 5 oxygens out of an O2 to balance that out? Okay? And what we can do is the following. We can take an O2 molecule and we can cut it in half. Okay, and when you cut it in half, you get a half of an O2 and a second half of an O2, which gives you 1 oxygen atom and 1 oxygen atom. So if you want to have 1 oxygen atom, that's going to be equal to a half an O2 molecule. Did that make sense? Okay. Now that deals with 1. We could also say, what if I want 3 oxygen atoms? Well, let's draw 3 oxygen atoms. And remember, each of these oxygen atoms is a half of an O2 molecule, right? We got an O, and then there's our other half that's missing, and then we got another O, and then there's the half that's missing. Yes, so we have a half of an O2, and we have a half of an O2, and we have a half of an O2, and that gives us 1 O and 1 O and 1 O, and that gives us 3 oxygen atoms. How many halves is that? 1/2 and 1/2 and 1/2 is 3 halves. O2 molecules. So these two are the same. So if you want 3 oxygen atoms, you can use 3 halves of an oxygen molecule. All right. Now, what if you wanted to have 5 oxygen atoms? How many O2 molecules would that be? 5 over 2. Okay, and if you wanted to have 7 oxygen atoms, that would be 7 halves O2. Okay, and if you're having trouble visualizing that on the next page, we have pictures for you. Okay? So say you needed 5, you've got a half of an O2, 1, 2, 3, 4, 5 halves O2, and you have 1, 2, 3, 4, 5 O atoms. Okay, and then I did not draw it for the 7, the 9, the 11, the 13. But what if you wanted 157 O atoms? How many O2s could you use? 157 over 2. Yes? Okay. So let us try an example. This first one, you could easily balance this without using a half at all, but let's just try using a half for fun, okay, for funsies. See how it goes. We have a Ca plus O2 gives CaO. I didn't leave enough room for a chart, so I'm going to make my chart up top. I've got a calcium and I've got an oxygen on the left. I've got calcium and oxygen on the right. I have 1 calcium, 2 oxygens. I have 1 calcium and 1 oxygen. Could I fix this O so that instead of having 2, I have only 1? I could put 1 over 2 here. Okay, and that would change my 2 to a 1. Now this thing is balanced. However, we don't like to leave things with halves in them. How do you make a half into a whole number? You have to multiply it by something. You have to multiply it by 2. So we're going to take this whole equation, and I think I did it down here somewhere. We're going to take this whole equation, we're going to put it in brackets, and we're going to multiply it by 2. So we have 2 times, well, there's a 1 in front of the calcium, so 2 times 1 is 2. We have 2 times a half is 1. I'm not going to write that 1 because we don't actually write 1s as coefficients, but there is a 1 there. Okay, and then we have 2 times, there's a 1 there, so that's going to be a 2. So that would be our final answer. So if you use halves, about half the time you will have to multiply your equation by 2. The other half the time you won't need to use a half, and you'll just be like, oh, I'm done. Okay, let's try an actual, what? Why do we use fractions? Because it makes our lives easier. Okay. It wouldn't for this question because this is a super easy question, right? But why do I show you super easy questions first? Because it's easier to do and easier to visualize. Yeah? I wouldn't use fractions for this question. It's just too easy. Let's take a look at this one. Okay. We have C2H6 plus O2 gives CO2 plus H2O. So we have 2 carbons. And remember, what order are we going to balance our elements in? First, we're going to do carbon. Second, we're going to do hydrogen. And third, we're going to do oxygen. So let's start by balancing our carbons. We have 2 carbons, so let's put a 2 in front of the CO2. That changes our carbon to 2. I could change my oxygens, but I'm just going to be mucking about with the hydrogens as well. So I might as well wait to change my oxygens until I've messed about with the water. Does that make sense? Yeah? Okay. So I have 6 hydrogen on the left. So if we put a 3 in front of water, that also gives us 6 hydrogen on the right. Yes? And now I can look at my oxygens and say I have 2 times 2 is 4 oxygens. And over here I have 3 times 1 is 3 oxygens. That gives me a total of 7 oxygens. And this is why we use a half, because now we can just say, oh, I need 7 oxygens, but I've got an O2. How can I get 7 oxygens out of an O2? I can use 7 halves. And that gives me 7 oxygens to pair with the 7 oxygens over on the right. So now we have 2, 2, 6, 6, 7, 7. We would then take everything and multiply by 2. Okay, so down here we've got it somewhere. 7 halves. I showed you the whole picture and everything. Okay, so we would take this whole thing and multiply by 2. So we have 2 times 1 is 2. We have 2 times 7 halves is 7. We have 2 times 2 is 4. And we have 2 times 3 is 6. And that would be our final answer. Is good? Okay. Shall we try this one by the other method? Okay, this is method 2. Step 1, double the hydrocarbon. Okay, the method 2 is not in your book. We're just going to write it down here. Okay, we double the hydrocarbon. We balance C, then H, then O. And then there's a step 3. We have to check to see if we need to simplify. So double the hydrocarbon, balance C, then H, then O, same order as before. And then we check if we need to simplify. You cannot forget that last step, otherwise you're going to lose like a mark or something like that. Okay? So let's try this one here. We have C2H6 plus O2 gives CO2 plus H2O. And we're going to start by doubling the hydrocarbon, which means we're going to put a 2 right here. Okay? So that is going to mean you're never going to have to work in halves, but you might need to simplify at the end. Okay? So you can always start by doing that. And we're going to say, okay, I've got carbon on this side is 2, hydrogen is 6, and oxygen is 2. Over on the right, I've got carbon is 1, hydrogen is 2, and oxygen is 3. And you might notice that it's always 1, 2, 3 on the right. Yeah? So now let's balance our carbon. 2 times 2 is 4. So let's put a 4 here. That gives us 4 carbons. And I'm not going to worry about the oxygens yet because I'm going to be mucking around with the water, so that's going to change again. Next, we balance our hydrogens. Hydrogens come second. We have 2 times 6 is 12 hydrogens, and I should have changed that to a 4. So we now need 12 hydrogens on the right, so we're going to put a 6 in front of the water. That gives us 12 hydrogens. Now, how many oxygens? We've got 4 times 2 is 8, and we've got 6 times 1 is 6. 8 plus 6 is 14. So we have 14 oxygens, which means we can put a 7 in front of the O2, and that will give us 14 oxygens. Now we have 4, 4, 12, 12, 14, 14. We're done. Okay, are we not? We have to check and see if we need to simplify. We have a 2, we have a 7, we have a 4, we have a 6. We're good. We do not need to simplify. Nothing is divisible by, like, there's no, what is it, lowest common, like greatest common multiple, lowest common denominator. Anyway, whatever one of those things, they don't have a factor in common. Whatever it's called, the greatest common factor, that's the one. Like, it's the lowest something, the greatest something, I don't know. Anyway, we're going to try one more. You might want your own paper for this one. Okay, we are going to do, let me just see. Where is this one? I have to pick the right one here. Okay. We're going to do C5H12 plus O2 gives, what are the products of any combustion reaction? You take carbon and you put it together with oxygen. And what do you get when you put carbon with oxygen? Usually, you get carbon dioxide. Now we're going to take hydrogen and put it together with oxygen. And what do we get? Water, H2O. So if you're ever wondering, what are the products of combustion? Take your carbon and put it with oxygen. Take your hydrogen and put it with oxygen. You get CO2 and you get H2O. All right. Let's try this one with our double, the hydrocarbon. CHO. And then 3, simplify. Okay, I got carbon, hydrogen, oxygen. I got carbon, hydrogen, oxygen equals, 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 equals. Over here, well, actually, I want to put my, before I do anything, I want to put my 2 right in front. Okay, because that's going to, that's what I'm doing. I am doubling my hydrocarbon. So now we have 2 times 5 is 10 carbons, 2 times 12 is 24 hydrogens, and oxygen I have 2. And over on the right-hand side, I have 1, 2, 3. 1 carbon, 2 hydrogens, 3 oxygens, because that's what I always have on the right to start with. Balance carbon first. I need 10 carbon. So I need to put a 10 in front of the CO2. That changes carbon to a 10. I have 24 hydrogen. I've got an H2O. That means if I put a 12 in front of that, I get 24 hydrogen. So those match up. And now we look at our oxygen and we say I have 20 oxygen and I have, I have 20 from the carbon dioxide, and I have 12 from the water, which gives me a total of 32 oxygens. So let's make that a 32. What times 2 gives us 32? 16. So I've got 16 O2, and that means now I have 32. Am I done? Simplify. So we're going to check. Is there anything that you can divide all of them by? Is there a greatest common factor? Yeah, and it's always going to be a 2. So just check to see if you can divide by 2. So what we would end up with then is 1 C5H12. Do I write a 1? No 1. I take 16 and divide by 2, I get 8 O2. 10 divided by 2 is 5 CO2. 12 divided by 2 is 6 H2O. If I did this using halves, let me just do this really quickly for you. C5H12 plus O2 gives CO2 plus H2O. I'm just going to do it really, really fast. I'm going to say I need 5 carbons, 5. I need 12 hydrogens, 6. And then I say I need 10 oxygens and 6 oxygens. That is 16, that's 8, and I'm done. I'm done. And I didn't have to do any halves because I didn't need it. So this is faster, but I don't know. It depends. It depends what you like, and it depends if you're willing to learn a new skill that might be a little bit challenging for you. The halves method, when you have to use a half, can be challenging. But like I said, it can be a powerful tool that can save your butt from the fire when you get a really weird question where you just need an odd number and you have an even number. Okay? So your choice. What you do, I'm going to get you guys, we're not going to do the big bad reaction because it takes a long time and I don't think it's worthwhile. If you're ever interested, you can look at it. It is possible, and you can end up with numbers that are 4, 91, 76, 34, and 4. Super exciting, but you guys are going to work on pages 43 to 45. Okay? No. You choose whether you use the doubling or the halves. I need to see that one. Quiz. So 43, 44, 45. What is the answer key upside down? Why is the answer key upside down? So you can't see it too easily. Okay. Oh, by the way, the pioneer video didn't work. Yes, or it didn't work. No. Okay. Yeah. Okay. I don't think we really need the Tyler video. It's kind of there. This? Yeah. No, I'm talking about the previous one. Oh, no. I don't think 6.3 or 6.1. Yeah, that'll be. Oh, okay. The one that that's fine. Oh, yeah. This doesn't have time. I have to search up the name. I don't know. I'll show you. Thank you. I'm glad you can't believe me. I have a graduation paper. Oh, okay. So, you know what? So they Is it the same name, right? Synthesis and decomposition. I don't think it's correct review. No, that's actually necessary. Okay. No, it was like a really great class. Wait, what? Okay, that's like 4th grade. I was terrible. Absolutely. I'm gonna keep pausing. No, it's great class. Oh, you see which one it is? What are you going to do now? No. What do you see?
Thank you. But this thing doesn't make sense. I leave my more stuff in there. I helped. It shouldn't do that. When I heard the first, when I saw the first story, I was like, I know it's bro, I just teach it. Bro, A plus B, so we need to use something else to add for. If you know that you know. With that, I think this.
Folks, if you want to check your answers, they are on page 45 at the bottom. It just gives you the coefficients. Okay.
You good? What's that? What's that? We have teaching. Yeah, the big one. So we want to see use that for one together. We also can do the two classes. What's going on?
I just because
Oh, wait, it's
like every time I say it, it's not even
Please no.
sadness. I just get really, really bad.
It's 8? Let me see. Actually, it is. It's supposed to be 8. So it's 8. That's crazy. Yeah. I don't know. Start when you again.
Okay.
That's really not today.
No, I got it. So I'm sorry. So you break it down. And F2. And you look all this the compounds are like dry. So N into F2. Why is there S8?
Because that's how they exist.
No, okay. That's what you think. Oh, you did start.
No. And I will always write those ones for you at the top, but you do need to remember to look for them.
Okay.
Right? I'm not expecting you to memorize them, but you need to remember, oh my gosh, sulfur and phosphorus are weird. Yeah.
Yeah, it's the good color. Like you acid. It wasn't like it was like solid for release. I know, but like even there it was weird. Yeah, the names are always weird for solid. Yeah, that's crazy.
That's like that's 8. But then there's also like 4 spheres.
So when you gotta do these
Oh yeah, you're like
So it's one so you're always here and and then
this one
check to see.
Because there's two.
Always done that way.
You divide it by two.
This one?
It's two, so this one always did.
Oh, yeah, it's all good. Oh, you want that? But I just say.
Yeah.
No.
We go in that right now, you go on the way. Now you have this. Pero, without me there.
So bad, and I went to it.
Thank you, bro. Yeah, this is simple. Now you
Yesterday.
yeah, CLH with
I lost my
you three.
I wanted the normal socks in my still like
So it's gonna be CL two, like that, right? So you see here, see it? Now, if you go to the home.
Folks, we're gonna be moving on. Students who are lollygagging around doing nothing, then you're just down on the car.
Yeah, I'll take it out. Come on. Okay, so CL has its own go 18.
I would really like to finish this one.
So CL 18.
Okay, I'll give you another 5 minutes to work on this stuff. Okay?
Hi.
Ooh, that's really nice.
Yeah.
GA. Oh, GA plus four.
Yeah.
Plus three.
Yes, I know. I turned it off.
Oh,
Yeah.
A.
I just see the car.
Sorry. Three.
No, mine's on.
I thought you
No.
were.
Oh, no, that one
How
over
did it
there.
go plus three? No, that's a fraction.
I learn to do it all the time.
So many speakers are dividing it 7 over 2. Because there's 7 options on the right side. We are okay. So we are going to need to solve it over 2. We are no charges.
Or you are doubling nice. So you have 206 and you have 12 items.
Is it?
So now we have, now you're
Yeah, right.
Here you go. It's one.
Formic acid. Is that it? Hydrochloric acid. HBO. Yeah. Before. Got it.
And at this point now you say like.
And
the
2.
oxygen-
And 2 charge. Or N3. And 3. EA has how many? 2. So
8 plus
EA 3 and 2.
6, 8 plus 6 is 14. And then it's like. Oh.
2 and 1. There you go. Yeah. Oh, it's all good. Maybe 5. 1.
Oh, you don't actually write the book yet. Just will save you. Yeah.
No,
And then this
AL,
one doesn't have any.
yeah, AL, 2, S3. Ooh, wait. Yeah. That's this one. 8. So it's 16, 30,
So, like,
16, 30.
don't get a visa and I go back, but I can't come back.
S.
Like, if I don't.
That's how many
get
is that?
my
Positive. S.
and I go back, and I'll
How many is
come back.
what's chargeable? So they pass me to now. Oh. Well, nothing, that's it. No, what? Four was the SC.
Good.
What? What do you mean?
I'm gonna recommend that you
Four.
start by going to.
So SC 4B. Is there anything else to do? Nope. Nope. Don't do it. Because if you do that, I have to do it. I don't want to do anything else. We've already had it. So it's only here. So you must say it. Takes me more happiness. Very possible. I'm just one.
Yes. And now you can say how many oxygens are on this side. On this side. Eight and a half there. One, yes. Yes. Okay, so you always have to live in that balance. And then you might end up with long years of like this. Yeah, and that's the back. So what you're going to do is start with just right. And that's just us. 2 parliaments. And now, we go carbon first, then hydrogen, then oxygen. Carbon here. Or it's 8, so yeah, so that's not now you're trying to see. You want it, you get 8 what times? 2, 7, 4, 6. And now, we your carbon here. Now your oxygens, we have 2 times 3 is 4, plus another 4, that gives you 8. Okay. And so you now have 8 oxygens, so 8 oxygens go into that. 4. Now you're done. Except you need to check and see all of the items. Yeah, so what you're gonna do is cross that over 1. Yeah. Oh, that was okay. Yes. So now what you're going to do is you're going to say now 4 carbons to 4 carbons. Well, I'm never sure to go. Yeah. Since was Plus 8 is 4. How is that 4?
Okay, folks. I'll let you have a little more time later to work on those, but I need to interrupt you to learn how to predict some products. So we are going to go to page 56. All of the reactions on page 56 are decomposition. So we're always going to be starting with a compound. So an A element stuck to a B element. Yes, they're stuck together. What do we do with it when we decompose them? We rip them apart. So what we're going to do is we're going to try a couple of these, and we're just going to rip the elements apart. Okay, so let's do the first 3 together. Okay? So I have an N and an F, so I'm going to rip them apart, and I'm going to have an N, and I'm going to have an F, and you'll notice I'm leaving lots of space. Was that easy? Okay. Next one, I have an Ni and an O. I'm going to rip them apart. So I now have an Ni and an O. I'm going to rip apart. I'm actually going to do number 4 here. I'm going to rip apart hydrogen and sulfur. Now, I'm not done yet, because lots of elements will just be the single element, but you have to remember that we have all the elements that when they are own are diatomic. We have Brinkel off.
Let's see if they're all here. See, is here, Owen is here, and Noah is here. Thank you.
Celia. Owen.
You pass that over, please.
And Noah. So, back to this. It would be incorrect to write N because N is diatomic. So we need to write N2. It would be incorrect to write F, so we need to write F2. Okay? So the first thing, number 1, is we write the formulas. Only after we have written the formulas do we balance the equation. Okay? So now that we have the actual correct formulas, we can balance the equation. Over on the left-hand side, we have 3 fluorine. On the right-hand side, we have 2 fluorine. How do we balance something when we have an odd number and an even number? Lowest common multiple, which is 6. So we're going to put a 3 here. That's going to give us 6 fluorines. We're going to put a 2 here. That's going to give us 6 fluorines. And I already needed 2 N's, so I'm all done. Is good? Okay. Is nickel a diatomic? No. I mean, you can check your list. You can look on the periodic table. Nickel is not a diatomic. So don't write a 2. However, is oxygen diatomic? Yes. 2. So we're going to put a 2 in front of the NiO, because that's going to give us 2 oxygens, so there's 2 on both sides. That means we also need a 2 in front of the nickel. Okay? Now we ripped apart the hydrogen and the sulfur. Is hydrogen diatomic? Yes. Now there are 2 other elements you need to watch out for, and those are S and P. S and P. For whatever reason, they just are that way. I will write these at the top of any quiz that you write, but you have to remember to look at them. Yes? So when I have a sulfur, it's not just S, it is S8, which means that when we balance this, it is going to be 8 sulfur, which means now I need 8 H2s. The balancing part is going to be easy, okay? I'll tell you the most common mistake that students will make. They will see NF3 and they'll say, ah, that makes N and F3.
Yeah.
No. Okay, N is diatomic, it needs a 2. Fluorine is also diatomic, it needs a 2, not a 3. You have to write the correct formulas. You can't just keep the subscripts from the reactants. Okay, so don't be doing that. Give a few of these a try. All right, and we're going to also cover synthesis before we leave today. So these are on page 56.
Oh, yeah. Yeah, what? When you see something? Wow. I think you're probably are. Yeah, I think you're expecting this. S was S8. Yeah. Was. Okay, it's gonna be SO, right? It's not gonna be SO2. We're gonna say by something.
If you finish page 56 in your board, you can try page 57.
Eight for me and I got 2 more to go. What is ammonia?
So I have 6
I think I forgot. I remember what do you memorize? You memorized that. You memorized it. You did. Yes, you did. You liar. You liar. This is you make myself really feel it. I don't care how much time we have after this. I don't care what else to do anymore. I don't care what pages there are. I don't know if you know them. This is the last thing we're doing for today. Immediately comes. Okay, ready. Calcium. Wait, you have to have right here. Calcium is Ca. Ca home. Silver. Aluminum is positive. Yes. Oh yeah. Something not this seriously. Let's think about it. It's like a reasonable thing to do. Okay. You know what I'm saying? I think we should not. Hey, what are we doing here? Are we doing? Oh yeah, right. Oh, yeah, because yeah, although I have to say, yeah, see, there were a lot of reactions. Oh yeah, got a good memory. Here we go. Yeah, sulfur has a charge of 2 plus.
It was so hard, but
Oh,
it
copper,
was
copper, yeah, sulfur is
matters rather than learning.
Okay, phosphorus, that's an acid. Oh, it's definitely C. What is it? P4? P4?
In 1990.
What is CUS? That's all. Sure, these are solid. Good, yeah. And what you can see if you read.
Okay, so over here we have.
Oh, wait, the application moves through?
Yes. Yeah. This is 6, this is 16, 6 of the opening is 5.
Calcium.
Now we have 6, 7, 20. So 20 minus 2 is 18. Yeah, I believe that's a lot to here. So I need the other.
Wait here.
Yeah.
We're really so good.
Yeah.
What's NH3? What's it? Ammonia? NH3. What is that? I know, but what is that? The gas?
No, in fact, it's good like not, it wasn't even ready for the shot.
Okay, friends, we're going to go to 6.3c. And I know someone had their hand up and I did not get to you. I'll come over to you in just a moment. I'm sorry. Okay, so now we have the reverse of decomposition. Now we are doing synthesis. And so I'm going to give you an element, and you are going to need to write the compound. And you're going to need to use all your rules of writing compound formulas, like you did in your naming and formulas test, yes? So, if I was to give you let's say I gave you Cl2, chlorine, plus aluminum. Okay? That's my element and my element. Diatomic, non-diatomic. Can I do the following? Compound. Ooh, that looks weird. Let's fix that one. Cl2Al. Do we love that? How much do we hate that? You should hate it a lot. What's one thing that's wrong with it? What's wrong with the formula Cl2Al? Yeah, the nonmetal cannot go first. We have to put the nonmetal second, okay? So we have to put the metal first. So let's try it again. I'm going to get rid of that. Metal first, non-metal second, Cl2. Yes? In a compound, it's not diatomic, right? So maybe I should just have AlCl. Do we love that? How do we write formulas for ionic compounds? Do we just go potassium phosphide? Calcium chloride? Sodium oxide? Are they all just 1 and 1? No, how do we know what the numbers are? We looked at the charges. So the metal has to go first, and we have to balance the charges. Okay? So aluminum is 3 plus. Chloride is -1, so it has to be AlCl3. Okay? So when you are writing your product, you can't just cram them together. The metal has to go first, and you have to balance your charges. And once you have that, you can use coefficients to balance the equation. And once again, we have a 2 and a 3. Our LCM is 6. So if we put a 2 here, that gives us 6 chlorine. If we put a 3 here, that gives us 6 chlorine. And that means we need 2 aluminum. So let's put a 2 there, and then we're done. What is chromium made of? It is made of chromium.
I know.
Like it's an element. I don't know what to tell you. Protons, neutrons, and electrons.
Is it like a solid element or is it like a gas or a solid?
Is chromium a metal or a non-metal? It's a metal. All of your metals are solid except for mercury. Okay? No, mercury is a liquid. It's the thing that they used to have in thermometers before it became too dangerous to work with, because we figured out that it caused cancer and made people go crazy. Yeah. Shall we try another one? Let's say we have, let's pick one. Ooh, this one looks fancy. No, let's not do that one. Let's do scandium and P. Who is the metal? Scandium. Scandium is the metal. It is in column 3. Okay, so it has a charge of +3. Okay? So scandium is +3. Phosphorus. What's the charge of phosphorus? -3. Oh my gosh, this one is just SCP. Woo! Look at that. That's crazy. So if we put a 4 here and a 4 here, we're good to go. But you have to make sure you balance those charges and that you put the metal first. Okay? So give a few of those a try. Whatever you haven't finished, of 43 to 40, don't ignore the last 3. They are different. I know some people are like, oh, I did most of them and I'm good. If you don't do like 9, 10, and 11 or 10, 11, 12 or whatever the last 3 are, you will have missed out on stuff. Try some of 58.
So there's no. ammonia is for this way as ammonia. For the naming, you have to put the numeral and also it is polynomial.
Oh, I said, because I said there's 4 phosphorus on the left, so I get 4 phosphorus.
Okay, fine. We do this, but then we're done. 3 more to go. Okay. With that mindset, you need to do 3 full pages of work. You know what that means? But I'm too lazy to do anything. Because you do it.
I'm so annoyed.